Hello everyone, I am Dean Wu of the Koace Institute of Chemistry, and I meet you again. Continuing with the topic of the last lecture. Conveying block in the threaded element of the twin screw extruder. From this section, what I want to share with you is the shear block. Let us still take the 65 machine as an example. Then I will focus on sharing 4 aspects with you. First of all, let's name one of the threaded blocks. As an example, we usually see that there is a threaded element that is written like this: 30 degrees 7, 64. So what does it mean? The first 30 degrees refers to it is that, and the cut piece is 30 degrees. The second, that there are a total of 7 pieces in this cut piece. 7 cut pieces. And the last 64 refers to this: the total length of the screw is 64. This is the first point. The second 7 means, in the 65 machine, we often see a shearing angle in the threading machine. For example, 30 degrees, 45 degrees, 60 degrees, reverse 45 degrees. So what is the difference? Usually, the larger the degree, the worse the passability of the cutting material in it. And 90 degrees, the shear caused by receiving the shear force at the same time. Then when the degree is large, the plasticization of the material. For a shear dispersion of glass fiber and a dispersion of inorganic fillers, it is a good help. Of course, for some heat-sensitive plastics or some materials that are sensitive to heat, use a large angle. This kind of cutting block is obviously inappropriate. This is the second point. In the third aspect, we also mentioned a forward direction and a reverse direction. In our cutting block, it also has an L behind the letter. For example, at 45 degrees, there are forward and reverse directions. The normal situation of the forward direction, the following, is that it is consistent with the conveying screw element, so its passability will be better, and the reverse is opposite to the material conveying method of the conveying thread element. So in this place it will generate a local resistance larger. So the resistance generated by the shear at this place will be greater. So it is helpful for the dispersion of materials. Of course, it should also pay attention to its shear heat. Fourth, we also have different lengths for the same angle. For example, the length of 5 pieces of 96 at 45 degrees, and the length of 5 pieces of 44 at 45 degrees. Obviously, the thickness of this single piece is different. When the thickness of the angle-compatible single piece is different, the thicker the thickness, the worse the passability of the material, and the greater the shear generated in it. So we have to treat it separately. So to sum up, for shearing, under the condition of a certain thickness, we usually have the largest shear at 90 degrees, followed by 45 degrees in reverse, then 60 degrees, and then 45 degrees. And the shear is the weakest, it is 30 degrees. Focus on cost and reshape the new value of materials.